Using the OSHA reports images, we see the scaffolding. This is 12, 11, and that's 10. We look at the scaffolding, and this is the scaffolding I think would have stayed in place. Possibly this would have been removed when they post-tension 11 here, creating the cracks in here. We're looking at the wrong side. It's presented to us from the CEI. I believe it's the other side presented to us. Or did I assume that? It could be this side. We see down 10 and 9 where they meet. Here's your scaffolding setup. It's not setting on any concrete. In fact, they just look like regular wooden boards down the bottom of the base. Look at the base here, the scaffolding. Just sitting on wood, which is just sitting on spot load points, just spot points, if you will, on soil. It does not appear to be concrete. As I look down this entire surface, it appears to be a regular surface, a granule surface. Of course, water, things like that could undermine each one of these easily. This appears to be a pipe clamp style. We see the extension pass here. Nothing where I would see that this deflection couldn't take place. That deflection couldn't take place. It appears that one I-beam or beam rather, goes across here. You see right here and here, possibly straddling between the two of them, between 9 and 10 being straddled by these two guys like a railroad tracks. So the center point, the center load distribution would be probably another plank going across here, which then goes to these planks. I don't have the access to the underside of them. The point being is that now we're looking at the scaffolding that I'm saying deflected when they loaded 11. That the tension did not create a camber in here, which we would have seen a space at all these members, at this member here, camber up, we would see a space. I couldn't make the camber up happen. Every time I played around with this triangle multiple ways, I could not make a anchor point here. Adding post-tensioning here to the degree where it wouldn't buckle, I could not add the camber up. The counter loads, etc., just don't work. So I can have it go load down though, and that load down would then create the deflection in these members in the post-tension. This point here at the scaffolding, and that would then get us to where we get to the cracks, as presented by. I'm gonna keep this live, as presented by the OSHA report and also CEI. Let me see if I can get to the top of this. Okay. Okay, good. I just want to see if I was missing anything right there in particular. I have an issue with my bump down. Okay, so I need to get a picture. I need to get a zoom in on that. On part 4, I believe I was talking about the blister on the back of the deck being knocked off. As you can see, this is the part that sits on top of the deck, as you may know or may not know. And the blister part clearly could be the part that's somewhere to be found. But we don't get good reporting and investigative skills apparently from OSHA or NTSB. With that said, you guys want to hire me, I'll subcontract to you. I'll get you guys up to speed, even or not, get you a little educated too, put you in a room and beat your engineers up for you. With common sense. So let me race down here. Okay, there we go. So this is an opening. This is presented on 228. This is the deck creeping down. There's another image we'll present like that also. That might be the other end. Photo number 3. 228. 228. So we can use these parallel cracks to help you understand cracks. 228. So we got parallel cracks. How come we have, if we have sliding taking place by these other people stating this sliding has already taken place, at this deck, we do not see any sliding at the deck. We do see an opening here, and it gets wider and wider as I go up to it, which can only happen by the dip in the deck, albeit very small. And then this guy is also parallel to this. Same thing. It's on the verge of being wide, and not sliding. This is the blister bar referred to as part of the deck build. It was out there right out here and down. I believe when a deck got pulled over, this also act as a hinge effect, lifting 12 off beautifully so to not destroy. Another prying effect to not destroy the base, the J bars in here, etc. I talk about that. They would kick in. It would kick in also. It would lean inwards and create that blowout that people were so excited about. Part of that blowout is what is being referenced as. So here it is already failed, but there are the two. This is that blister behind it being held by 12. This is sitting on top of that blister. It's acting almost as one, apparently. Well, almost. Here's the tape measure that I want to show. It's lower on this side, 3 inches, and the other side, meaning a torque took place, and that's what it looks like from the top. And over here we have, almost 5 inches. So our torque is, as we're looking from this side, it looks like the top would be right to the right, clockwise. We're engineering positive, negative. Yeah, that would be negative rotation. So I'm showing you that. So clockwise. And then here, this is that elevation I speak of where it's higher. This means the top of 12 is now leaning in, albeit very small, but this is exponentially. It looks like this. It's being lift up also, not just down. It's being lifted up by the hinge ability and the spring ability of the post-tension longitudinal cables, C2 and C4. At that hinge point where it fails, that's the point. It's as I showed in the previous video. These are further down the line of failure. This is the torque action I explained, trying to say I can show where the torque stopped, and it's going to be a little further up than that. So that's the gap right here. So the torque action of that rotation clockwise resolves itself right about there. No more torque is taking place. At the base, you see where the torque is right here also on this guy. This is inwards. This right surface is to the right, and the left surface over here of this line is closer to the left of us, or closer to us here. This is further away if we're looking at this section here. And as I zoom out, everything changes again. So this is closer to us. So ultimately, everything on this side of the line appears, except for I can't see behind the tape measure. That would be a spot, a pivot point if that was the case. But it all appears closer to us, and this appears further away. So the torque, you can visualize the torque now. Oh yeah, so I looked up master and expert. I think I would consider myself a crack expert. A master is the higher one over expert. So yeah, I'm not master yet, but I would consider myself an expert. That's a tension break. This is at the pipe or so. This is what a part that's going to tear off. I want to get you one image to end this video. One image, baby. So I talked in the previous videos, 1, 2, and 3, about the bottom of the deck, and I talk about the nut. Obviously, here's the nut. There's the plate still in place. They're the threads. How did they determine that, right? How did they determine 50-50? And if so, we should be, and these only 2 inches off longer, we should be able to count the threads on here and see an equal amount of 50-50, if you will, 50 kips, 50 kips. I do not think we would find that. Not at all. I don't think that would reveal itself as such. And of course, the photograph is cropped not to show the end of that, so I can get a thread, so I can get a look at the threads. Of course, OSHA has access to this right here. Of course, they could have not cropped it and showed us the end. I'm sure he didn't photograph it. I am confident he didn't photograph it, or she didn't photograph this with this angle like this going over top of that. I am confident that this all got photographed as evidential, but it's coming up shy. The thread count would have told us. I don't see it 50-50 happening. So the shear was claimed, and you see there's no shear here. There's got to go through these stirrups. That didn't happen that way. This chunk of concrete, this is the one that's got me. I really wonder if that's the bottom, the 12. Is that the 10-inch? Is that the 10-inch part that I've been talking about? I wish we could see the other side of it to see if it's got a pipe configuration in it. But that's the bottom blister being ripped off, being torn off, knuckled off, if you will, and it would tell us a story also. This does not appear to be cut. This goes all the way into there. Yet the OSHA report shows it sheared here with the words sheared. If you guys can see sheared here, you're better than I am. I know I don't see sheared there. As we go further down this photograph, though, we see the words, and somebody commented in my video that it was sheared right here, lower post tension bar of diagonal 2 sheared. Yeah, that's not falling in my happy zone there. Okay. I want to show you the bottom of this. This is that part where I talk about it rotates around, where I say that the blister bar participated in the outside blister of this, which is poured in one pour. So I shouldn't be calling it a blister, but I am, because the other thing stands on top like a blister. This is supposed to be poured in one pour, and this would be it here. If it's poured in one pour, the blister had reinforcement in it. I believe this is the reinforcement that you see standing up. That possibly one or two pieces of it are the reinforcement standing up that went into the back of 12, that 10-inch. And you see that it is how it's configured. It's straight in the air. Many people keep asking about these bars and other forms. I know it to be, in my opinion, these are the blister bars, the blister of 12. It's reinforcement. You see the way it is shaped. This means it was ripped out by a shear effect of this going down on top of the pier, and that staying at the pier and pulling and sliding up. Doing so, lifting 12 off. So yes, I was trolled by someone about 12 can't be lifted off. Well, bite me. That's a technical term that means bite me. So let me do this. I'm going to pause it, and I'm going to get you something else. Why would they show the opposite non-failed end also? You know, isn't that non-relative to where we're focusing? All right, so the blister bar is this little lady right here. That little blister, what I'm calling a blister bar, this 10-inch. It ripped off, did the lift off. Let me pause this and get you something. So what I'm trying to show you is the impact of that blister right here, center line of the structure. This could also be part of 11, so I can't nail that to you, but this is how I see it being ripped off and creating this beautiful liftoff of 12, and also 12 being flipped back over with the same thing. Remember, the blister is part of the deck, that blister bar that sticks out, not part of 12. It is part of 12 as it is encompassed in it. You would also see that part of that would be this guy here. Let me pause. So right here is where I have the blister bar coming in contact with the pier, and as the deck is still going in a downwards motion, it's flipping, or it's also or up here it might got entangled in some rebar reinforcement up there. that bottom blister or back blister bar is able to lift off the 12, and you get this beautiful J bar right here. You get this beautiful J bar left behind because of the effect of that, and also the crushing. The thing's already been destroyed. All right, so Linda Fig, Denny Pate, NTSB, OSB, QRSB, all of you guys, you want somebody to have a little fun with you, with evaluating your broken structures, please get hold of me. I'll take your money. I'll take your money. I don't think Linda Fig and I'm going to go bankrupt. They got too much. They own too much. So there you go. Let's see what else we got. There's one more thing I thought. Oh, again, brain power. Your brain is the key here, not a computer program. You guys are falling for this computer program stuff, and you would love to see it in a computer modeling. Well, the computer model can do anything it wants to do, and you would believe it. You guys sent me over to a guy to look at his computer model. He wrote me before he put that model up and said that this is what we think happened. And I was like, what? You just stole my idea. And then you post a video after you write me and say this is what we think happened. But the thing is, I looked at his background and all, and I was like, oh no, this guy's, you know, I felt sorry for him. Not in a pity sense, but I guess so. And that he's trying. If you see a story, he actually makes it clear on his channel there. And I was like, oh. I was like, nah, I'm not going to kick this guy. I'm not going to kick him down. I'm not kicking him down. I'm saying that it would have been nice for him. He could do a nice rendering for me, but he couldn't follow that video I stated. He couldn't translate it to his own 3D modeling. And I was like, darn it. Maybe I will get hold of him. Maybe I will ask him to go partner with me here. But I don't know if he can pay attention, because he didn't pay attention to how I stated. He had it moving a different way and flexing, and it doesn't flex like that. It doesn't. None of this bridge is flexible like that. They're breaks. It's not flexing and swinging like some of these videos keep showing, like a damn rubber band. All right. Bye. Love you all, you guys. Hope you enjoy this one. Whoops. Can't miss this opportunity. For everyone who talks about shearing off the deck, this will be the bottom of the deck. Shearing is going this way, supposedly, going through the deck. So you have the material here missing. This guy was in here somewhere. This was already planted. Where did I find it? It was here, and the path is already there. Anyway, you guys look here. It doesn't work out that way. It doesn't work out that way. You can't see it from here. Okay, before I go though, of course I keep finding something else I want to share in one video. This is the back of 12 apparently. See the back of 12? 12 was up here. Now look where it is. This is that reversal I told you guys about that took place there. There's a reversal. That's B, as I call B, the upper one. And this is 11, and it goes down underneath the deck behind here. This goes down into the deck, but that's 12. But look where it is. It had to go through some concrete in there. Or did it? How did it go through concrete that was supposed to be between these two guys? Did this not have concrete between 11 and 12 properly grouted? Because how did it blow through there without causing the rest of this failure? That's the one I hope you guys can tag on to. The other group can tag onto this and then start having a little fun with that. It goes nowhere. It just talks about craftsmanship.